Okay, welcome back. So today we're going to be doing some more KVL and KCL. For this circuit right here, I've made a little bit of a plan so we can go ahead and start solving this circuit. So the ideas that we're going to read off this checklist, and as we go, we're going to make like a predefined set of steps for you to do in case you're stuck with solving circuits. So in this one right here, we're going to identify what we are solving for. And written right here, we're solving for VG and IG. So we can say that one is done, nice and easy. Now we're going to acknowledge the sources that we have in our circuit and the effects of them. So right here, I see that I have my 100-volt source and I have a current source. So this current source is IG. Now, that seems to be the only sources I have, but I am also given some information in the circuit to help me start solving. So right now we can go ahead and check off this guy. So I'm given in the circuit that this current, which is already defined as IB, is a value of -2 amps. Now I'm also given that this current IA is a value 4 amps. So uh, that step is done. I've seen what I need to see in my circuit, so I know I'm familiar with the elements that I have. Now what I'm going to do is make some voltages. And now I have to be very smart about how I choose my voltages. Now I'm choosing to put everything in the direction of a voltage drop. That way I can go with regular passive sign convention. All right. So in this case, I see my current IB. So my mental plan is to go ahead and put this in direction of a voltage drop. All of these elements are going to be in series. This 11 ohm resistor and this 9 ohm resistor are going to be in series, all right, with the 10 ohm resistor. So therefore, they all share the same current, which is IB. So I want to put all of these elements in a voltage drop, in the direction of voltage drop. So let's go ahead and do that. I'm going to use red for that. I'm going to have this one be minus or positive minus, and this one's going to be called V11. This one's going to be called V9. While I'm at it, I'm also going to go ahead and define a current over here in purple. This is going to be IC. All right. And much like I did with IB, I'm going to put this in the direction of a voltage drop, and we're going to call this one V5. Now, for the 30 ohm resistor, I'm going to define another current. I'm going to call this ID. And ID is going to go in the direction of a voltage drop as well. So let's go ahead and do that. This is going to be right here. We're going to call this V30. And like I said before, we're going to go ahead and put this resistor with a voltage as well. So I'm going to choose this polarity right here. Alrighty. So now that I've done that for this top loop, I can go ahead and do it for the bottom loop. Now, in order for me to do this, I want to do it with respect to my current. I'm going to call this guy IE. Once I have my current IE in, I can now write a voltage drop. I'm going to name this one V4. And because I know that IE, this is a one node right here, same node connected by one. Therefore, this one is going to be in series with IE. So the same current IE travels through here. All right. So I can go ahead and label this one in the direction of a voltage drop as well. And this one is going to be called V16. Now, the cool thing is that right here, I also have this voltage, which I can do V15. But look at what I'm given. Because I'm given IA, I already know what the voltage value of V15 is. All right, and this will come in handy later. So we can go ahead and check this off our list. We've labeled all our currents and our voltages. Now, we are going to verbally and mentally go ahead and plan our steps. So if you want to skip ahead to when I start solving, that's cool too. But I'm going to go through a little bit of mental planning that I like to do when solving these kinds of circuits. All right. So what I would do is, because I understand that there's two known currents and one unknown current, I'm going to go ahead and use a highlighter here. I can go ahead and solve the current IC, right? Because I have IB coming in to this node, I have IA leaving this node, and I have IC defined by me to be leaving this node. I can go ahead and find a solid value for IC. So I'm going to I'm going to call this find IC by KCL at, and let's go ahead and call this node A, at node A. All right. From there, once I see I have IC, let's see, I can go ahead and find V30, right? Because I know what the value of the voltage drop is here because they give me resistance and they give me the current, which is -2 amps. So because I know the resistance and the current, I can find the voltage. Same story with this guy right here. Because I know the resistance and the current that travels through it, I can go ahead and find it. Once I've already found IC, that means I still have the same scenario where I have a resistance and I have a current that's known, so I can find V5. In order for me to do that, I also need to include this component right here, which is V30 or 30 ohm resistor. So I don't know any information about it, but the point of me doing a KVL in this top loop is that way I can include V30. And once I get V30, I can pretty much figure out my ID from that due to Ohm's law. All right, so that's going to be our step 2 is going to be KVL. Let's call this guy loop 1. KVL in loop 1, point of that is to find V30, and consequently, we're going to find ID. Alrighty, so from there, I see that once I've found ID, now I have enough information again to find IE by KCL. Do you guys see that? So I have this current right here, which is the same IB leaving. I have ID coming out of this direction as defined by me, and I have IE. So by KCL at a certain node, which I can call B, by KCL at node B, I can find IE. So I'm going to write that down, find IB, or sorry, IE by KCL at node B. Alrighty. Once I've found IE and ID, and IC, I can now find IG. Otherwise, I could have found IE in this like intermediate step right here, but I'm gonna just to be safe, I like to find IE. All right, so let's go ahead and expand on this. So my knowns at this point, as far as currents go, is gonna be IC, ID. Therefore, I can find IE, or sorry, IG. Find IG by KCL, and I'm going to call this node C at node C. And let's go ahead and highlight this node. We'll call this C. All right. Once I've done that, then I can go ahead and do a KVL. Again, I could have done this KVL earlier in the steps. Like I said, this is my plan that I like to do, so feel free to do your own. From here, like I said, I'm going to do finding VG. find my VG by a KVL in loop. I'm going to call this loop 2, L2. All right. Once I've done that, I've found IG and I've found VG. All right. So let's go ahead and implement these steps now. So, like I said, we're going to go ahead and find IC by KCL at node A. So to find KCL to find IC at node A, I'm going to write that I have a minus IB. I'm going to have plus IC, and I'm going to have plus IA equals to 0. And I'm doing this solely based on my passive sign convention. I say that IB is entering, therefore I denote it as a negative. I say IC is leaving, so I put it as a positive. I put IA because it's leaving. All right. In solving this, I get that IC, based on the values of -2 and 4, is going to give me that IC equals to -6 amps. All right. So that is done. Now I'm going to do a KVL in loop 1 to find V30. So in doing this, based on the voltages that I've written, I'm going to write in terms of voltages, and then I'm going to transfer into my currents and resistances. All right. So my step 2, let's make a little partition here. So we're going to have minus V9 minus V11 plus V10 plus V30 minus V5. And that's all going to equal to 0. So, like I said before, paying attention to passive sign convention, this is where it's going to start getting a little bit funky. So V9, let's just look at that one element. So I know that for this, because I'm putting the direction of a voltage drop, I have to obey my passive sign convention. This current that I've written right here is equal to -2 amps. So based on this, I can say that this is going to be a minus 18 volts. All right. Let's look at this element right here too, this V11. So for this V11, I see that I have my IB and my resistance. My IB is -2, my resistance is 11. Therefore, my voltage V is equal to RI is going to be -22. But I've chosen to do my KVL in this direction. Negative, negative, positive, positive, negative. All right, that has some implications. Because I've chosen to do it that way, I have to keep track of my signs. All right, so let's go ahead and write it out and break it down step by step. So V9. V9 is going to be composed of my 9 ohm resistor and my current IB. So minus stays from this guy, from my KVL. My V9 is going to be -18 minus my V11. My V11, like I said before, was going to be -22 plus my V10, which is going to be, now, because I've chosen this polarity, I have a negative V times I, right? Negative V times I. So I'm going to have -10 times -2, which is going to give me a 20. So I'm going to have a 20. And from this, my V30, so plus my V30 and minus my V5. So minus my V5 is going to be minus, my passive sign convention says IC, so it's going to be -6 times 5, which is going to be -30. So I'm going to have a minus -30 equals to 0. So cleaning this up, I get 18 plus 22 plus 20 plus V30 plus 30 equals to 0. Solving for V30, I'm going to get minus 18, minus 22, minus 20, minus 30, which equals to negative 90. It's going to be negative 90 volts. So I found V30 as negative 90 volts. Therefore, I can go ahead and jump a little bit of a step. Because I found V30, I can also find ID. ID is going to be my negative 90 divided by my 30, which gives me a negative 3 amps. All right. So I have done this step. This guy is done. This guy is done. Equals to ID. All right. Now I want to find IE by KCL at node B. Let's make a little bit of a break right here. All right. Finding IE by KCL is going to give me plus IE plus ID plus IB equals to 0. So these are all my variables, but I need to put them in terms of numbers now. All right, so let's go ahead and get a solid number for IE. IE will equal to minus ID minus IB. When plugging this in, because I found ID to be negative 3, I found my IB to be negative 2, which was actually given to me. I'm going to say that IE is actually 5 amps. All right, so I've went ahead and found IE, and I've confirmed that it's 5 amps. All right, so let's go with my next step. I see that I have IC, I see that I have ID, and now I can find IG. All right, so by KCL, I'm going to have minus IC plus IG minus ID equals 0. I'm going to say that IG equals to IC plus ID. Therefore, IG will equal to negative 9 amps. All right, this is done. Now I'm going to go ahead and find my VG by KVL in loop 2. So by KVL in loop 2, I can go ahead and say that I have my, let's see, I have plus V5 plus VG minus V15 minus 100 equals to 0. So algebraically solving now, I'm going to have VG equals to, let me go ahead and do this step by step. So I'm going to have V5 plus VG equals to V15 plus 100, so that VG equals to V15 plus 100 minus V5. All right, we already know what the current is that's going through 15, so I know that VG equals to, V15 is going to be equal to R times I, which is going to be 15 times 4, which is going to be 60. So we're going to have 60 plus 100 minus V5. Well, V5 is going to be, V is equal to Ri, so I'm going to say that 5 times this is negative 30 minus a negative 30. All right, so I have 60 plus 100, that's going to be 160. 160 plus 30 is going to be 190. So I'm going to say that VG equals to 190. All right, and that concludes today's video. Thank you so much.